it's handy to consider data values in terms of how many standard deviations that one value is above or below the mean. We call that a z-score. When we calculate a z-score, it tells us, this is our x-bar, it'll tell us how many standard deviations we are below. These are negative z-scores. Or how many standard deviations above, these are positive z-scores, that a particular piece of data is. So, if we consider the area under a curve to be 1 unit, or 100%, we can calculate the percentage of the area above or below a particular score using the following charts. And it's similar to seeing that certain percentage of students got between a 45 and a 75. What we're going to be looking for is the area under the normal curve to the left of z equals -2. Well, here's our x-bar, and if this is 1 standard deviation, that would be a -1 z-score. This is 2 standard deviations, that would be a -2 z-score. This would be a -3 z-score. A 1 z-score for 1 above, a 2 z-score for 2 above, and a 3 z-score for 3 above. We have charts that will tell us the amount of area to the left of all the z-scores. And we can use that to determine how many students did better than this certain score, how many did worse than this certain score, how many did between these two scores. To find the area of the curve to the left of z equals -2, in other words, we want to know what's the area of this part of the curve. We're going to go to our tables, which you have in your notes. This is the table of area to the left of z, and we have one table with negative z values and one table with positive z values. We go down to the 2, and this is -2.00, and we find that the area to the left of that is 0.0228. So I'll go back here, and the area to the left of this is 0.0228, or little under 5%. And that makes sense since we've decided that 95% is between the -2 and the 2. So about half of 5% would be below -2, and about half of 5% would be above 2. What about to the left of z equals 1.57? So 1.57 is somewhere in here. And this time we're asking for the area, all of this area. So it's going to be pretty big. It's got to be at least 50%. So let's see what it is. We'll go to the positive chart. We have 1.5. We go over to the 7 to get 1.57. And we get 0.9418. Or again, that's 94.18%. Is to the left of 1.57. So if we were asking what students had a z-score of less than 1.57, we'd say 94.18% of students had less than a z-score of 1.57. What about to the right of 1.57? So we're not asking for this red shaded zone, we're asking for this green part. Well, we already said that altogether this whole curve has an area of 1. So to find to the right of something, we'll look up the number on our chart, and that'll tell us to the left of it, and then we'll take that away from 1. And we get 5.82% or 0.0582. That's the area to the right. Okay, what about the area between z equals negative 2.32 and z equals 1.57? Let's clean up our graph a little. So we've got negative 2.32 is right here. We've got 1.57 here. We know that the area to the left of 1.57 is 0.9418. But we don't want this part from here down. We don't want to include that part. So what we need to do is subtract that off. So the 1.57, that's nice that we've already done that. We will subtract from that whatever the value is for negative 2.32. And for that I need to go back to my table. We'll start at negative 2.3 and we'll go to our 0.02 column, and it looks like negative 2.32 has a z, the area to the left of that is 0.0102. So I will subtract that from 94.18 and I get 0.9316, or if we were looking at it as a percent, 93.16%. So when you want to know the area between two values, you find the larger z-score, find its area to the left, then subtract off the area to the left of the smaller z-score.